So in the last video, my challenge was to find the general equation for a parabola with a vertex at hk passing through the point pq. So we recall the general vertex point formula for parabolas. That's y equals a times x minus h squared plus k. Well, we are given that it passes through the point pq, so we can substitute p for x and q for y. And what we really want to do then is we were already given an x and a y. We already know h and k, we were given that. So all we need to do is to solve this equation for a. So we want to first put in the values of p and q for x and y, and then we solve for a. So a is equal to q minus k over p minus h squared. So let's put that back into our Desmos. Okay, I'm going to hide these other things just to get them out of the way. We can just delete them. You just click on the X over here. So I'm going to delete all of this stuff here. And now we're left with just our point on the parabola PQ and our vertex. So we're going to define an A to be equal to the quantity Q minus K divided by the quantity P minus H caret 2 for squared. So you can see that it's already computed that because we know values for all four of those. And then we're going to just type in a general formula. I always like to use a function notation there. G of x, which is equal to a, which it knows what that is, times the quantity x, because we want the general formula, x minus h squared plus k. Ha! Look at that! Isn't that cool? So the point on the parabola stays on the parabola, and as I change the vertex stays, but the vertex moves, but the point stays the same. And this is the fun of Desmos, is you set up these challenges for yourself, and then you say, oh wow, this is really cool math. This is when I actually use the math that I used to just memorize. So I hope that that has been fun for you. Another thing that you might want to do is to shade. So suppose we want to shade the inside of this parabola. Well, what you can do is you can just make this greater than, let's see. Oh, it doesn't want to do that with, okay, let's do it this way. It doesn't want to do it with that kind of notation for some reason. Let me just change this to y. There we go. I'm not sure why, but for function notation doesn't work as well. So when you say y is greater than, then you have the shading to work. So, it's good to make mistakes because we all learn from them. So now you've got, you can come up with the shading for it. All right. Next thing we're going to talk about, I'm just going to clean this all out. I don't know of a quick way to clean it all out, but the next thing to do is to come up with, my new challenge is to come up with a square. Let's just say it's a 2 by 2 square. Okay, just a 2 by 2 square. So I'm going to ask you to pause the video this time and see if you can come up with a 2 by 2 square. Well, actually, let me give you a hint. The first part is you want to be able to control the domain and the range. This is a huge asset, another huge asset that Desmos has. So if I want to have a line right here, that's the first side here, I'm going to just say x equals 2. As you can see, there's the first side of our square, but we only want the square to go from 2, 0 to 2, 2. So what I'm going to do is I put curly brackets to contain the range of the function, because I want it to only go for a range of 0 to 2. So I want y to go in between 0 and 2. So you can see right already when I hit less than or equal to 2, it controls the domain there. So that's exactly what we wanted there. I'll make that a little bigger, zoom in a little bit more. Actually, you can also go here to projector mode to make it a little bit darker too. So now we want a line that goes from across here. So from 0, 2 to 2, 2. And we want to control, this time we want to control the domain. So now we're going to have y equals 2. As you can see, that's the line at y equals 2, but we want to control the domain. So we're going to say 0 less than or equal to x less than or equal to 2. And now you've got your domain there. So that you've got the whole line, but now it's limited from x to be 0 to 2. All right, so now we sort of have a square. I guess we need to put in the other side here, which would be this line here is going to be x equals 0. Whoops. X equals 0. And again, we want to contain the range. So we want to say 0 less than or equal to y less than or equal to 2. Now that gives us that side. And finally, the last one here is going to be y equals 0. Contain the domain 0 less than or equal to x less than or equal to 2. All right, so now we have our four sides. Now suppose that we want to shade this. Well, we could try shading, how about just in between the purple and the red. We could make the purple, we could say y is less than 2. Okay, that worked, but now the problem is it's still exceeding this part here. So what we could do is contain it so that we have a second control here, right? Because what we're doing now is we've got the domain for the x contained, so that the y is less than 2, so it's got it's going this way, but it's also going down here. Let's see if we can just put another bracket right here and say 0 less than or equal to y less than or equal to 2. So there you can see that we've got actually the shading, because what's happening is before we were just containing it, the domain going this way, and now when we do this, we're also containing the range, or saying you can only shade from y is 0 to y is 2. So that gives you kind of a cool insight into how you can create an entire square. We could make an entire square with just one function, and that's one challenge. And I'm going to give you a second challenge, and that is, instead of having it at 2, 2, I want you to have it at a free point. Let's just use PQ again. So challenge 1, see if you can come up with a shaded square with just one instead of 4 lines. And challenge 2, instead of making it at 2, 2, make it a square at P, Q. Actually, it'll be a rectangle at P, Q. All right, that's my second challenge.